We determined that here, at least, Gabby, put your mask on. At least in this section of Texas, we say roly-poly. And people have heard people say pillbug and doodlebug, but nobody knows what a slater is. I looked it up. Apparently it's another word for these little round things. Anyway, if one of these things has kinetic energy, it must also have blank. Now, I'm getting there. I told y'all, I gave y'all a hint. I said, okay, look at these formulas. So let's look at the formula for kinetic energy. 1/2 mv squared. So if it has kinetic energy, that means its kinetic energy is not zero. That means its mass isn't zero and its velocity is not zero. Because if one of those is zero, 0 times that will be 0, and then it won't have kinetic energy. So it's got a mass and a velocity if it has kinetic energy. So the other formula with mass and velocity in it is this momentum formula. See? Mass, velocity. If it's got a mass and a velocity, it's got kinetic energy and momentum. So the answer is momentum. Oh, yes, Gabby.
My computer isn't working.
Yes, I know. They are not working. So people at home, if your computer is working, I mean, of course, like you can listen, you can hear me, so then good. We're having problems here. Having problems for 3 weeks. Oh. Well. Today, we're going to remember everything about momentum. Tomorrow we're going to review. Next day we'll test. And if y'all can't get to it, I have paper copies up here. So I'm going to show you these things. So your things today will have 2 different kinds of momentums on it. It'll have the momentum problems that are elastic, which is the ones that bounce apart, boing. And they'll have the inelastic ones, which is the ones that stick together, like that. So the elastic ones, you got 2 objects before, and then you got 2 objects after. The inelastic ones, you got 2 objects before, but then they stick together afterwards. See, you can see them sticking together. And we've done problems of each of those. Most recently we did an inelastic one, so I'm going to work the elastic one today. So you have a bear cub here, 20 kilograms. Fun fact, cub is the guy that is fixing my dad's truck right now. I had never changed my oil myself, and we tried to do it yesterday, and we got the oil out and put new oil in.
Wait,
but
you've never changed your
we weren't smart enough to get the filter off, but it's going to have to be changed anyway because it's leaking real bad, and he's going to have to put the dye in it, the UV dye, to figure out where it's coming out, and I think it's pretty fun. Anyway, 20 kilogram bear cub going 4 meters per second. That's object 1. So mass 1. Gabby, are you listening?
Yes, sir.
So object 1, so mass 1's 20, and V1 is 4 meters per second. That bear cub runs into a stationary 2 kilogram small tree. Okay, so that V2 is stationary, so that's 0. So that small tree is M2, and it's 2 kilograms. Oh. Okay. Uh-oh. No. Afterward, where is it? Oh, here we go. After the collision, the bear cub stops. So that's that 20 kilogram bear cub. So that's object 1. M1 is still 20, and V1 is as it stops. So it's 0 after the collision. Okay. And then how fast does this small tree move away? That's a 2 kilogram small tree. So afterward, M2 is still 2 kilograms, and we're looking for what V2 is going to be. Whew. Like I said, the hard part about this is writing all this stuff down. The math is easy. So, okay, I got my M1 V1 plus M2 V2. That's the momentum of the system before, because, you got the system here. 2 things are moving, and that's the whole momentum that we've got to have the same as before as after. So this is the before, and it's got to be equal to the momentum after. Since these 2 things, so this doesn't say that it bounces apart. And when you're looking to figure out which one's elastic and which one's inelastic, it won't always say these bounce apart. This one sticks together. But it does say that after the collision, this one stops and this one moves away. So you can tell that they're separate afterward. And that's how you know that it's elastic, because there's two objects after and they're not stuck together. So I've got two objects then. So the momentum of the bear cub plus the momentum of the tree is equal to those momentums before are equal to those momentums after, of the bear cub and then of the tree. All right, so now I can plug everything in, and then I'll be ready to do the easy part, which is the math. Okay, so on the four variables, M1 is 20 kilograms, V1 is 4 meters per second, plus M2 is 2 kilograms, and V2 is 0. Afterward, M1 is 20 kilograms, V1 is 0, M2 is 2 kilograms, and V2 is what we're looking for. Whew, okay. Okay, that's the hard part. Now is the easy part. Here we go. 20 times 4 is 80, plus 2 times 0 is 0, plus 20, or equals 20 times 0 is 0, and 2 times V2 is just 2V2. And now I can simplify. 80 plus 0 is 80. 0 plus 2V2 is 2V2. All right, here we go. So it says V2 times 2, so I'll divide both sides by 2. 80 divided by 2 is 40. And that's a velocity, so it's meters per second. That's a 2. There. So please start that assignment. I'll be providing paper assignments if you're having technical difficulties.